Woohoo! Example 4. More of this factoring quadratics and solving them. This next example, we're going to turn up the heat a little bit because I think you guys are that good. I think you can handle it. All right, let's say that we want to solve something like this. 6x squared minus 6x equals, whoops, that's a crappy 6, negative 2x plus 16. All right, what's our first step? First step, get what on both sides? Get what on one side? 0. We need to get 0 on one side of our equal sign. It's really a trade-off. There's two things on the left we could move to the right. There's two things on the right we could move over to the left. But remember what I said. We generally like to keep our first number that's next to the squared letter positive. Let's move the stuff on the right over to the left. And I'm going to do this in one swoop. The opposite of subtracting 2x would be to add 2x. I'm going to line up my like terms. And the opposite of adding 16 would be to subtract 16. I kind of offset it over here. Okay. All of this stuff cancels out on the right, and that gives us a big old 0. And notice on the left-hand side, what are we going to get? We're going to get, writing this in standard form, 6x squared, negative 6 plus 2, reading this from top to bottom, is negative 4x. Negative 16, there's nothing to combine with it. Negative 16 is just going to drop down. All right, looks good. Step 2, factor out the GCF. Now, the GCF of the left-hand side is not 1. What's a common factor of 6, 4, and negative 16? 2, right? We can factor out a 2. And when we factor out a 2, we have to think to ourselves, what's going to be left over when I pull that 2 out? What would I multiply 2 by to make 6? 3, right? First piece is going to be 3x squared. We're not going to change the exponents on our variable because we're not taking any x out. We're just taking a number out. The exponents are going to stay the same. What would I multiply 2 by to give me negative 4? That would be negative 2. X comes along for the ride. That's going to stick around. What would I multiply 2 by to make negative 16? Negative 8. And this is still set equal to 0. Now, since we just have a number outside of our parentheses, we can really divide both sides by 2 and get rid of that 2 that's outside the parentheses, because it's just going to be a distraction, I think. So let's just divide both sides by 2. Get it the heck out of there. It doesn't need to stick around. It's just taking up space. It's useless. And let's just focus on what really matters here. And that's factoring this expression 3x squared minus 2x minus 8. Now, this is not a naked quadratic, it's a dressed quadratic. And what that means is we have to first multiply front end times back end. What is 3 times negative 8? Negative 24. We need two numbers that multiply to negative 24, but those same two numbers have to add to what's in the middle. What's sandwiched in the middle? A negative 2. Oh, come on. Okay, pretend that's a 2. Okay, that's supposed to be a 2, not a good one. What number multiplies to negative 24? Two numbers that multiply to negative 24, but those same two numbers add to negative 2. What do you got? What do you think? How about 4 and negative 6? I think that'll do the job quite nicely. 4 and negative 6. Let's check. 4 times negative 6 is negative 24 indeed. Happy time! 4 plus negative 6 is negative 2. Sweetness! All right, we've got our lucky lotto numbers. Now, what time is it? What time is it? Yes, table time. Exactly. It's table time. We're going to make our 2 by 2 table. And remember how we fill this table in. First piece, first box, last piece, -8, last box. And then along our diagonal, these two empty boxes, we're going to drop in our lucky lotto numbers, our 4 and our -6, but we have to remember to attach the variable to it, which is x. Okay, let's start factoring out our GCFs of each column and each row. Rows go left to right row, both start with R. Columns go top to bottom. Let's check out our first row. What can we factor out here? The biggest number that goes into 3 and 4 is 1. I'm not going to write the 1, but you could if you want to. And we take out the smaller of the two exponents. This exponent is 1, even though we don't write it, and the smaller one is the mightier one. It's the one that wins. We can take out a single x to the first power, because we want to factor out the smallest number of factors of x. I know that sounds really weird, but what I mean by that is this x squared means x times x. It has two x's being multiplied. This only has one x. The smaller number of factors wins. 1 factor of x, 2 factors of x, 1 wins, factor out x. The second row, what can we factor out of the second row? We can factor out a 2, and remember the sign closest to where we're factoring is the winner. All right, we're going to factor out a -2. Along the first column here, what can we take out? 3x, exactly. 3 goes into both 3 and 6, and that's the GCF, the biggest number that divides into both. Nice job. And the smaller of the two exponents is 1, the smaller one wins. That's why we're taking out a single x. The last column, the biggest number that goes into 4 and 8, I'm going to ignore the negative, is 4, and the sign closest to us carries. This is a +4, so the positive is going to carry, and the GCF of 4 and 8 is 4. And there you have it. We've got our factors, 3x plus 4, x minus 2. And those two factors we're going to write side by side now in their own little nook, their own set of parentheses. 3x plus 4 equals 0. Oh, snap. I didn't mean to write that. Sorry. Can I undo this? Come on. Hey. Hey, undo. Okay, it's not working. Sorry about that. All right, just ignore that. I'm still trying to get used to this smart board. Sorry for that. I jumped ahead, didn't I? Thinking about that KFC that's waiting for me at the house. You have no idea how hungry I am. Okay, equals 0. All right, so what we want to do now is set each factor equal to 0, which I, like a dummy, did a little bit too early over here. Sorry about that. We're going to set each factor equal to 0 and solve for x. Okay, that's looking good. For the first equation, we want to get x by itself. To do that, we're going to subtract 4 from both sides. That gives 3x equals -4. How do we get x by itself? We need to unglue the 3. To unglue the 3 that's multiplying x, we divide both sides by 3. And that tells us that, hey, come on, one solution is -4/3. Okay, and we really want to leave these as fractions. If you take -4 and divide it by 3, you're going to get a repeating decimal, and it would be -1.3 from here to Chicago and then even further. Just leave them as fractions, please. For the second equation, to get x by itself, we're going to add 2 to both sides. So the other solution is x equals 2. And there you have it, peeps. Another quadratic equation solved by factoring. I hope you guys are having as much fun as I am. I could do this all day and night. But then again, you know, I'm a big nerd. What can I say? All right, anyway. 2 more videos to go. You guys are doing great. I do appreciate you taking the time to watch these. It's going to pay off in the end. See you in a little bit. Adios. Bye-bye.